Hello everyone. So in this video we are going to solve advent of code day 10 problem, which is cathode ray tube problem. But before solving that, if you have not subscribed to my channel, then please do. It really helps me keep motivated to make new videos. So let's move to the problem. So in this problem you will be given a set of CPU instruction. So here there are two type of instruction. One is loop and another one is add. So loop instruction will execute in one cycle and one CPU cycle, and add instruction will execute in two CPU cycle. And what add instruction will do, it will add whatever value is here into the register. So for example, initial value of a register is 1. Then what loop will do? It will do nothing, means it will not add anything to the register, but it will take one CPU cycle. So loop will take one CPU cycle to execute. What add x will do? It will add x plus equal to whatever the value, and it will take 2 CPU cycle. And so in this problem we are asking to find the signal strength. So what is signal strength? So signal strength is basically the multiplication of register value and the number of cycle at that time. So this is a signal strength. So let me just walk you through the example. So but before explaining the example, it is saying that we have to find the signal strength depending on some criteria. Like we have to find the signal strength, like here it is asking us to find the signal strength for values like 40, 60 and so on. So let me just check that value here. If you see, it is asking us to find the signal strength for CPU cycle, 20th CPU cycle, 60th CPU cycle, 100th and 140, 180, 220. Okay, so this is what it is asking. We have to add all of the signal strength value at these CPU cycles. So let me just walk you through this example. So here first instruction is add x 15. So initially our register will have x equal to 1, and if it execute and cycle, if you take cycle equal to 0, so this will take 2 CPU cycle. So not CPU cycle will be 2, and value of this register value will be 16. If you move to the next instruction, this is again add x. So value of this one will be 4, and the register value will be 16 minus 11, which will be 5. If you move to the next, so now again add instruction, it will 6, and the value of this register will be 11 and so on. So if you move to this instruction here, it will cover almost 19 CPU cycle, and if it again move to the next instruction, which is add x, it will take 19 plus 2. But before that we have to find the signal strength, right? So when it execute one CPU cycle, then it will reach to CPU cycle 20, and at the CPU cycle 20 we are asking to find the signal strength. So what we will do, we will just multiply whatever value we get in this register and whatever value we get in the register. So let me just check what value we are getting in the register when this instruction comes, like add -1. So at that time we get 21 value in the register, and we get 21 value in the register. So register value is 21, and number of CPU cycle is 20. So if you multiply it, you will get like 420. So this one is the signal strength. Now again, if we move to the next CPU cycle, and when we reach to CPU cycle 40, let me just check, either it is 40 or something else. So if we reach to 60th, not 40, if we reach to 60th CPU cycle, then again we have to multiply it with by the register value and number of CPU cycle and add the previous value as well. And at the end of all the instruction, we have to return the signal strength value. So let me just walk you through my code which I have written. So first I will clear my screen. Let me just walk you through the code. So here, if you see, initial value for register is initial value for register. Okay, register is 1. CPU cycle, as I have told, I have initialized is to 0. Ignore this one, display and row value. I will explain it later because this is a part of part 2 problem. Now here I have defined the CPU cycles as mentioned in the program, so which is 20, 60, 100, 140, 180 and 220, right? Now I have defined age matching condition. So you can directly write it into code, but I have done it via one function. So here this function is checking if the current CPU cycle is present in this set. If yes, then return that true, otherwise return false. Now I have defined signal strength. This is a signal strength. This is signal strength, right? And initial value of signal strength is 0. Now I am just parsing every line, means every instruction present in the input. So here our input has lots of instruction present, so I'm just parsing line by line. So this loop is for that, and here I'm just splitting the instruction and checking if the first if it is a loop instruction. So if it is a loop instruction, then register value will not increment, right? As I have told you, only cycle value will increment. Ignore this part, ignore row and ignore from row to this if condition, because this is a part of part 2. I will explain it later. Now I'm checking after so let me just delete it first so that you won't get confused. Okay, so now after incrementing the cycle, I'm checking if the current cycle value is present in the cycle set. If it is present, which means our condition is satisfied, right? In that case, we have to find the strength. So what is the strength value? Number of register multiplied by cycle. So strength value is register multiplied by cycle. So that we have done. So and we are adding the previous value as well. So cycle strength plus equal to register multiplied by cycle, and we are adding it to the strength, right? Again, if instruction is add x, then what it will do? It will first increment by 2 cycle, and at the end it will add whatever value was present in the add instruction. So to increment, let me just delete this as well, because this was part of part 2 problem. So here what I am doing, I am just defining one variable t equal to 2. This is to because add instruction will take 2 CPU cycle, so that's why I have taken 2, and I am running a while loop for 2 times. Okay, here I am just incrementing cycle value and checking if this current cycle is matching current cycle value is present in this set. If it is present, then we have to increment the strength with this formula, like register into cycle, right? And I'm decrementing the cycle value, like first it will execute for 1 cycle, then again for 2 cycle, and if value is matching, then it will calculate the strength, and at the end I'm adding the register value to x. Okay, and at the end I'm just printing the strength value. Okay, so this is for the part 1 problem. Let me just walk you through the part 2. So if you see the part 2, in part 2 what it is saying, that you have one sprite. Sprite is basically a pixel, and means it contains 3 pixel. Okay, so you have one sprite and it contains 3 pixel. So what this pixel will do, it will be lit when it matches with the register value is inside this length of this pixel, otherwise it will be dark. So here if you see, representing each pixel on the screen as a hash, here is the cycle during the first and last pixel. So this is just saying how we are representing this cycle. And here it is saying that it is 40 length wide and 6 row means as a height, 6 row as a height. So here it is saying, if a sprite is positioned as such that one of its 3 pixels is the pixel currently being drawn, the screen produces lit. Means if the register value is present in the length of the current sprite, then it will shown as lit, means has, otherwise it will be shown as a dark. Okay, so that we are doing, right? So, and one more thing to notice here. So if you see here, register control sprite 3 pixel and X register set a horizontal position. So if you see the system, there are yeah, this one. If the register set horizontal position of the middle of that sprite, okay, so it start with the middle of that sprite, right? So this one you have to make sure. Now let me just walk you through the code. So let me just okay, so here what I'm doing, so as discussed in the part 2 problem, what it is saying, a current pixel length, if it is under the current register value, then it will display as hash, which means lit, otherwise it will display as dark, which is dot. Okay, so here what I'm checking, so for example, suppose register value is 1. So if register value is 1 and initially display will be empty, means all are dark, so what it will do, it will check if the length of this display is inside the range of this one, means register, which is 3 pixel. So it will start from 0 to 2. So if it is inside this range, then it will display it as hash, as mentioned. Okay, and again length will increment because we are adding it to the row, means adding it to the display. So in this case, again length will be 1. Again it will check if 1 is present in the range of this one. So if it is present, then it will display it as lit, otherwise it will display it as dark. So that we are doing. And what we are doing here we are checking if the current display length is 40, means 40 pixel, as I have told you. Width will be 40 pixel and height will be of 6 pixel. Okay, so width and height will be 40 pixel, and so that's why I'm just extracting. If length of the current row is 40 pixel, then I'm just appending that to the display, and I'm resetting the current row to means empty string. Okay, same we are doing here as well. Why we are doing here? Because this display will update on every CPU cycle. So one thing to note, display will update on each CPU cycle. That's why we are writing the same code block here and here. You can clean this code if you want, because this can be cleaned up, means there are lots of opportunity to clean this code, but I'm not doing it here. You can definitely write it down. But yeah, so that's the basic idea. Like on every CPU cycle, you see we have to update the display, so that's why we have written like this. And here as well, because here we are incrementing the CPU cycle. If you see here, CPU cycle is getting incremented and we are updating display, okay. Same here, we are updating display, okay. And at the end we are just printing the display value. So we are just printing the display value. So let me just show you how output for this code will look like. So let me just go to day 10, now run. So here if you see, the first part output I'm getting 17380. So if I compare, for the first part 17380, and for the part 2, what it is saying, you have to provide the what is the capital letter appear in your CRT. So what is the letter appear in your CRT? So let me just clear my screen. So what is the letter? So this letter is F, this letter is something like G, this one is C, U, Z, R, E, C. So this is the letter, it appears in the CRT, and if you see, this one is the correct output. So that's it in this problem. Thank you so much for watching. Please like and subscribe to my channel. If you have any doubts, do let me know in the comment below. I will definitely try to resolve your doubt. Thank you so much for watching.